All right, so you've probably seen LLMs do some incredible things, right? They can write poetry, summarize dense articles, even chat like a person. But what if we could get them to stop just talking and start doing? Well, that's where AI agents come in. Today, we're going to break down the 5 main blueprints for turning these amazing brains into actual autonomous actors in the digital world.
So the central problem here is actually pretty easy to grasp. Just imagine a super intelligent brain floating in a jar. It knows, well, almost everything. It can reason, it can write, but it's totally disconnected. It can't click a link, it can't run a line of code, it can't ping an API. It has no hands, no eyes. It's just stuck in there, completely cut off.
So the big question is, how do we build that bridge? How do we connect the LLM's thoughts to actual real-world actions? The answer is by building these clever frameworks around the model. And that's what we call an AI agent. And, as you're about to see, there's more than one way to pull this off. Okay, let's kick things off with a couple of approaches that are all about reacting in the moment. You can think of these agents as being really improvisational. They don't sit down and write out a big, complicated plan. Nope, they just figure things out step by step, grabbing whatever tool they need as they go. First up, we've got something called tool orchestration. The best way to think about this is that the LLM is the cognitive kernel, the brain of the whole operation. When you give it a task, it quickly realizes what it can't do on its own. It might think, hey, I can't actually search the web, or I'm not a calculator. So it acts like a super smart switchboard operator, patching the call through to exactly the right external tool to handle that part of the job. And the way it works is this really simple loop. It goes like this. You give it a query, right? The LLM thinks, okay, I need to find the current weather in London. That's the thought. Then comes the action. It spits out a command, something that looks like code, like search weather in London. The system takes that command and actually runs the search. And finally, the LLM observes the results, reads the weather report, and uses that new piece of information to decide what to do next. Now, the upside here is huge. This approach just massively expands what an LLM can do. It grounds its answers in real-time, live data, which really cuts down on the chances of it just, well, making stuff up. But, and this is a big but, there's a real cost. Every single one of those tool calls uses up tokens, and it adds a noticeable delay while you're waiting for that other service to respond. And what's more, the whole thing is a bit fragile. If that weather API is down, for example, the entire chain can just break. Okay, our second reactive pattern is called react, which, as you might guess, stands for reason and act. This one is really clever. The LLM doesn't just blindly call a tool. It actually weaves its reasoning together with its actions. It's basically prompted to think out loud, explaining its logic, and then take an action based on that thought, all within one tight, continuous loop. The loop here is super intuitive. It's a simple 3-step dance: thought, action, observation. First, the model writes down its thought, like, I need to find the final score of yesterday's game. Then it takes the action. It calls a search tool. And finally, it gets the observation, the result from that search. That new piece of info gets fed right back into its memory, and the whole loop starts over. Simple as that. And you can actually see what this looks like under the hood. The model literally writes out, thought, I need to search for this, followed by action, search with these keywords. This thinking out loud is so important because it makes the whole process transparent and allows the agent to correct its own course based on what it finds at each step. So, the big win for React is its simplicity and agility. It's quick, it's flexible, it adapts on the fly. But it has a blind spot. Because it's only ever planning one step ahead, it can sometimes get lost. It's like trying to navigate a maze by only looking at your feet. For complex problems that need a real long-term strategy, it can take an inefficient path. So, fantastic for quick, simple tasks, but it can definitely struggle to see the big picture. All right, so we've seen the reactive agents, the ones that think on their feet. Now let's shift gears and look at agents that are more like master strategists. This is a real step up in capability. We're talking about agents that create detailed, upfront plans and can even learn from their own failures to get better over time. First in this category is plan and execute. And honestly, the name pretty much says it all. The best analogy is a chef who writes out the entire detailed recipe before they even think about turning on the stove. You have one LLM, the planner, whose only job is to create that step-by-step plan. Then, a completely separate executor agent comes in and just follows that recipe, instruction by instruction. So the whole workflow is super structured.
The planner creates the master plan. The executor just chugs along, ticking off each step. But here's a really cool feature. It can replan. If the executor hits a snag and a step fails, it can actually go back to the planner and say, hey, this didn't work. We need a new strategy. Once everything's done, a final step pulls all the results together into the final answer. The big advantage here is that this method is way more robust for complex jobs. You get higher accuracy because the agent has that bird's eye view of the entire problem from the start. But here's the catch. It's all front-loaded. You're paying a pretty hefty price in both tokens and time just to generate that initial plan. And if that plan is bad, well, you're going to waste a whole lot of time and money executing a flawed strategy. Okay, this next one is one of my personal favorites. It's called reflection, and it's exactly what it sounds like. This is a system where the agent literally learns from its own mistakes. After it tries something and fails, it stops, takes a breath, and writes itself a little note in plain English explaining what went wrong and what it should do differently next time. It then uses that reflection to guide its next attempt. This learning loop is just incredibly powerful. So imagine the agent is trying to write some code. It makes its first attempt. An automatic evaluator runs some tests and tells it, nope, this failed. Instead of just trying again randomly, the agent reflects, my code failed because I didn't handle negative numbers. It stores that little piece of wisdom in its memory. Then, on the very next try, that reflection is part of the prompt, acting like a constant reminder. Hey, don't forget about the negative numbers this time. And the results? They're pretty stunning. On a tough code writing benchmark, a standard GPT-4 agent got it right about 80% of the time, which is good. But when they added this self-reflection loop, the accuracy shot up to 91%. That is a huge leap in performance, and it's all because the agent learned how to learn from its own failures. And our last major blueprint is the autonomous loop, which you might have seen in projects like AutoGPT. Here's the idea. An LLM just runs over and over and over in a loop, trying to optimize a solution to hit a specific target. It's a bit like a game of hot and cold. It tries something, gets a score, and if the score is better, it keeps going in that direction. It's always trying to find a better and better solution. Now, this can be insanely powerful for very specific, well-defined problems, like tweaking a prompt to get the absolute best performance. But, and this is a massive but, it has a huge catch. If you don't give it a crystal clear way to score itself, these agents have a nasty habit of drifting into chaos. They just get stuck in pointless, bizarre loops. Oh, and they are incredibly expensive, sometimes running for hundreds or thousands of loops and burning through tokens like crazy. It is the definition of high risk, high reward. So there you have it, 5 different blueprints for building agents. The obvious question is, how do they actually stack up against each other? Well, as you've probably guessed by now, it all boils down to a classic trade-off. There's really no free lunch here. Let's look at a head-to-head comparison. On one task, the simple reactive React agent got a pretty solid 85% accuracy, but the more thoughtful plan and execute agent, the one that thinks ahead, boosted that all the way up to 92%. That's a really meaningful jump in how reliable it is. But of course, that extra accuracy comes with a price tag. The React agent used around 2,500 tokens to get the job done. The more accurate plan and execute agent, it needed about 3,500 tokens. So you can see it right there. That extra reliability has a direct and measurable cost. This table really brings it all together. You can see the whole spectrum of options. On one end, you have React. It's simple, doesn't cost a ton of tokens, and it's perfect for things like interactive Q&A. On the total opposite end, you have autonomous loops. Maximum autonomy, but super complex and super expensive, so you'd only use it for very specific optimization tasks. And then you've got plan and execute and reflection right there in that sweet spot in the middle, giving you high reliability for tough jobs, but at a higher cost. So after all that, what's the big takeaway? Where does this leave us? The most important thing to understand is this. There is no single best agent. There's no silver bullet. Choosing which blueprint to use, whether it's React or Plan and Execute or any of the others, is a strategic engineering decision. You have to look at your specific problem and ask, do I need bulletproof reliability no matter the cost? Or do I just need a fast, cheap, good enough answer right now? And that leaves us with one last big question to think about. As these agents get more and more powerful, more and more autonomous, what's the one job, the one decision that we should never delegate to them? I'd really love to know what you think. Thanks so much for tuning in.